Hello, my name is Michael Wozniak. I'm a student at Rutgers University, and this summer I worked with Dr. Andrew Baker creating models of observed velocity widths of dusty star-forming galaxies at high redshifts. The two types of dusty galaxies I worked with are submillimeter galaxies and quasi-stellar objects. Submillimeter galaxies are luminous galaxies fueled primarily by star formation, and quasi-stellar objects have their luminosities fueled primarily by accretion onto supermassive black holes. The velocity widths used in the analysis were obtained from CO rotational lines from the gas reservoirs, powering the luminosities of each galaxy. The velocity width measured from the galaxy is often not the intrinsic velocity width of the galaxy due to its inclination angle relative to Earth. The equation at the bottom of the slide shows how the velocity width, delta v, is determined by a dispersion velocity component that is not affected by inclination, and a rotation velocity component whose effect on the velocity width does depend on the inclination. My main method of analysis was creating cumulative distribution functions, or CDFs, using the velocity width, dispersion velocity, and rotational velocity as parameters. To simplify the analysis, I changed the dispersion and rotation velocities into the Vmin and Vmax parameters using the two equations in the bottom left, where Vmin and Vmax are the minimum and maximum allowed values of the velocity width in the CDF. With these parameters, I used a Markov chain Monte Carlo analysis, which searches the parameter space to find the values which give the best match between the modeled and the observed CDF. In addition to the Vmin and Vmax parameters, I introduced the parameter C into the CDF to gauge the strength of the face-on inclination bias, giving the CDF equation shown in the bottom right. I also developed a model CDF which uses two galaxy populations rather than just one. With this method, one set of parameters is used to calculate a single CDF for each subpopulation. Because I assume that there are an equal number of each population in the set, each CDF is divided by 2, and the primary CDF that is compared to the data is calculated by adding each population's CDF together. An additional research point was replacing the Vmax parameter with the central black hole mass using the two equations below, which relate both the rotational velocity and the black hole mass to the stellar dispersion velocity. Here we have the results from an MCMC analysis of a set of QSOs, analyzing the strength of the face-on inclination bias in the set. The left figure is a corner plot showing the histograms and contour plots of each parameter from the analysis. In this analysis, the model prefers values of C greater than or equal to 15, and although the CDFs on the right are a close match, these inclination biases are too strong to be realistic. Here we have the resulting CDFs from an analysis of another non-QSO dataset, using the single population model on the left and the two population model on the right. Comparing the primary modeled CDFs in orange to the observed CDFs in blue shows that the two population model gives a better match to the data. Here, the left figure shows the corner plot from an analysis using the two population model, with the central black hole mass replacing Vmax as a parameter. The CDFs on the right show that using the preferred black hole masses from the analysis in units of solar masses in the model gives a close match to the observed data. To sum up, the single population method best matches the observed data at unrealistically high face-on inclination biases, but the two population model is able to give a strong match to the data without such strong inclination bias, and may better represent the properties of the observed galaxies. Future work can take this research further by relating the velocity widths to other galaxy properties, or can develop a new model with more than two populations, or a model with galaxy properties that vary continuously. I'd like to thank the New Jersey Space Grant Consortium for providing this research opportunity, as well as to Dr. Andrew Baker for his help and guidance with this project. Thank you for watching.